Hello guys, welcome to my YouTube channel Tech Help Club. So today we will discuss another dynamic routing protocol called OSPF, which stands for Open Shortest Path First. So I am assuming you all are aware about the basic networking concepts. If you don't know about OSPF, just go to the networking guides. We have available a lot of guides on the internet. Just do the Google and go through the OSPF first, then came back here to understand what I am talking about. So what OSPF is, let me give you the small introduction about OSPF. It is a link state interior gateway routing protocol which is used within autonomous system. So as its name suggests, shortest path first. So it works on the same algorithm, shortest path first, to calculate the best path based on the cost, which depends on the link bandwidth. Okay, so OSPF divides the network into the small areas. So we have a one backbone area called area 0. So all the networks who are going to participate in the OSPF should be connected to the area 0 directly or indirectly. So let me start our today's lab. Let me give you the topology. We will use the same topology we have in our RIP protocol. So if you haven't watched yet the RIP video, just go to my YouTube channel and search for the RIP and watch that video first, because we will use the same topology here and we will use few configuration same as we have in the RIP. So here we have our three firewalls: firewall 2, firewall 3 and firewall 1. Firewall 1 is an internet facing firewall, and is this firewall act as a boundary router or a boundary firewall. You can consider it as a boundary router. Okay, and we will set up a OSPF between all three firewalls to share or exchange the routes what they have or what they learned from their own network or what they have connected to their LANs. So here we have it 2.0, 3.0 and 4.0. So by enabling OSPF, we can ping from PC2 to PC1, PC1 to PC3 and PC3 to PC2, anywhere in any direction. How it is possible? Because we also have few policies configured in firewall 2, firewall 3 and firewall 1, which as I am using the same topology, so I am not going to configure the policies this time. I will show you later on what policies I am talking about. So in firewall 2, let's focus on firewall 2 first. So in firewall 2, if you want to allow the traffic from PC2 to PC3 or PC2 to PC4, there should be a policy which says the traffic coming through the port 2 and exiting through port 1 should be allowed. So we have to create a one policy in this direction and other policy in the reverse direction, so that if PC1 and PC3 wants to communicate with the PC2, the traffic should be allowed through the firewall 2. So we have to allow other policy, port 1 to port 2 in the reverse direction. Okay, in similar way, we have to apply two policies here in firewall 3, from port 2 to port 1 and from port 1 to port 2 to make the communication happen. And in the firewall 1, we have to apply one extra policies also. So first policy is port 4 to port 5, and second policy is port 5 to port 4, and third policy, we if you want to communicate to the outside world, we have to allow the traffic hitting on port 4 and port 5 should be allowed to port 2 in the forward direction. Okay, so we have to apply one another policy, port 4, port 5, and allow the traffic towards port 2. And also this is the internet facing firewall or router. So we have to configure one static route or one default route which is pointing towards the ISP gateway. So if any users sitting behind this firewall can communicate to the internet. And if you remember from my previous video, we have injected one default root in firewall 2 and firewall 3 users with the help of RIP. But here we will inject default root with the help of OSPF. So we will enable one default root inject option in the firewall 1, and it automatically inject the default root what firewall 1 is receiving. It will give that root, same root, to firewall 2 and firewall 3 in the form of E1 or E2 type roots. So I will explain E1 and E2 type roots later in this video. So this is the topology we will use today. So let's begin our today's lab. So let's configure the OSPF. I have already turned on all the firewall and all other devices. So let's go to the firewall 1. So for firewall 1, just go to the network, and if you remember from my previous video, we configured RIP, and below the RIP we have a OSPF. Just hit on the OSPF and you will see the router ID here to be configured. So what is router ID? So router ID is the unique 32-bit number that identifies each router in the OSPF. Okay, so it usually chosen as a highest IP address on the loopback interface, and if you don't have any loopback interface exists, the highest active physical interface IP address is used as a router ID. Okay, so let me used 1.1.1 for the router 1, and for area, as I said initially, there should be a area 0 connected directly or indirectly to the each network who is participating in the OSPF. So we are not making it complicated. So we will create area 0 itself, and we will put all the network in the 0 so that they can communicate. Okay, so here you can see the type is not we cannot select the type and it's grayed out, right? But if you will select another area type, let's say .1, then you can see these options are now enabled to use, but we are using only 0. So let's type 0 and it's disabled again. Okay, and we can opt the authentications, so that makes it more complicated and secure. So if you want to make any authentications between the OSPF network, you can opt all these options from here. Okay, let's hit OK. That's it. Now the networks, what networks you want to participate in the OSPF. So here you can see in firewall 1 we have 2 networks, 1.0, 4.0. so we have to add both the networks. Let's create, and it's the part of backbone 0, as I said. So here we have to put the network, hit OK, and again the second network, select the area, and the network is 1, hit OK. That's it. And we don't need to put any interfaces as of now, but if you want to put the interfaces, you can put the particular interfaces, because we have only 2 interfaces, which is the part of the OSPF. We are not using any other interfaces here, so it will work if we will not mention any specific port here. Okay, so it's on you how complex your topology is. You can use the interfaces as well. So I am leaving it as of now. So leave all the other options as it is. Okay, and hit apply. That's it. Okay, now go to the firewall 2, and the same way under network, go to OSPF. The router ID I am using for the firewall 2 is 2.2.2, and area, select area 0 and hit OK. That's it. Now create networks. And what are the networks on firewall 2? It's 2.0 and 1.0. Okay, so let me copy it. 2.0, go to the firewall, select area and network 2.0, create new and select another network which is 1.0. 1.0, hit OK, and that's it. Keep all the information default. There are a lot of other information you will see here. So you will see the default route inject. I will use this later on to inject the default route from the firewall 1 to other firewalls. And also there are a lot of other options if you want to perform redistribution from any other protocols, so you can opt these options here. Okay, and this is the distance value of the OSPF. So if let's say if you have a two protocol enabled here, RIP and OSPF, but RIP has the less administrative distance, so it will be preferable on RIP. Okay, it doesn't matter either you have configured both on the firewall, but it automatically opt the OSPF due to the administrative distance. Okay, so just hit apply here, that's it. And in similar way, go to firewall 3, go to OSPF and router ID. We will use 3.3.3. Create network area, keep it default backbone area, hit OK. Create networks. Now we have 3.0 network and 1.0 network. So let me copy it, select area and give the network ID, network subnet, OK, and create new area and give the another network which is 1.0 and hit OK and hit apply. Okay, now all the three firewalls are the part of OSPF and they starts communicating and sharing their routes with each other from the OSPF or the dynamic way or the based on the algorithm which OSPF used. Okay, so let me show you here. Go to the dashboard and network and expand this to full screen, and here we go. You can see firewall 1, this firewall is receiving route 2.0 and 3.0 through the OSPF. 2.0, 3.0 having the administrative distance 110, 110, which is the OSPF administrative distance, and here you can see. Okay, in the similar way you can verify the networks or the routes from the firewall 2. Go to network, expand it, and here we go. Okay, and firewall 3, go to dashboard, network, expand the full screen, and here we have a 2.0 and 4.0 through the OSPF. Now they can communicate to each other 2.0, 3.0 and 4.0. Why? Because I have already created a policy as I said earlier. So let me show you the policies. First of all, focus on firewall 1. Okay, so I am going to firewall 1, policies and object. Go to firewall policy. Here you can see we have a 3 policies here. First is LAN to WAN, which is used to communicate to the internet or to the outside world through these two ports, port 4 and port 5. Whatever traffic is hitting on these two ports can go outside with this policy. Okay, let's say if user 2 or PC2 wants to communicate to internet, it goes in this way from PC2 to firewall 2 and then go to firewall 1 via port 4 and allowed. And in firewall 1 we have a policy which is allowing the traffic from port 4 to the outside, and it goes to the outside world through this port 2. Okay, in the similar way port PC number 1 can communicate to the internet with the help of this policy. Okay, and second policy is LAN 1 to LAN 2, and third one is LAN 2 to LAN 1 in a reverse way, so which allows the traffic from port 4 to port 5 and port 5 to port 4. Okay, and obviously we should have a one default route towards the internet so that any traffic which belongs to the outside world can go outside through any specific port or the port which we configured to the default route. It can exit through that port. Okay, so go to the firewall 1, go to the network and go to static routes, and here you can see I have already configured one default route saying whatever traffic hitting to this firewall which is not matching to the particular network, then exit that traffic towards this gateway. And what is our gateway IP? 192.168.1.254, which is our WAN 2 port and is configured on the ISP router, which is further connected to the internet. Okay, so which makes the communication from this firewall or from other firewalls to go outside. But at this time, we cannot communicate through the PC2 and PC3. Why? Because we don't have any default route here, but PC1 can communicate. Let me show you the PC1 first. Here we have a PC1. Go to the terminal and try to ping 8.8.8, and here we go. You can see I'm able to reach to the internet from PC1. Let me try it with the PC2 and PC3. So go to PC2 and try to hit internet 8.8.8, and here you can see destination is unreachable. Okay, in the similar way from PC3, ping 8.8.8.8, and here we go. We are not able to reach outside. Okay, and let me minimize all these. Now focus on firewall 2. So firewall 2, we should have a policy which says the traffic coming to the port 2 and exiting to the port 1 is allowed, and then the reverse way also. So let's go to the firewall 2, go to policy and object, firewall policy, and here we have two policies, LAN to WAN and WAN to LAN. So don't confuse in WAN. I just named it as a WAN, port 1 as a WAN, and here also port 1 as a WAN, because these interfaces are the interfaces which is further connecting to the firewall 1, which are the internet facing interfaces. Okay, so let's go to firewall 3 and go to policies and object, go to firewall policy, and here also you will see two policies. Okay, all right. Now if you want to verify through the CLI, let's go to the firewall 1 CLI first. Okay, just log in it, admin and password, and get router info routing table and hit all, and here you can see. So this is the firewall 1, which is the internet facing firewall. Here we have a S star, means static default. So we are getting default route through the port 2. Okay, and other O stands for OSPF. We are getting these two routes through the OSPF, which I already shown you through the GUI interface on the firewall. Okay, now let's go to the firewall 2, admin password, and hit the same command, get router info routing table all, and here you can see we don't have any default route. So that's why these subnets which are behind this firewall cannot communicate to the internet. Here you can see we don't have any star route here, but we have a two route which are learned from the OSPF, so we can communicate to each other internally but not to the outside. Okay, in a similar way, let's check in firewall 3, admin, hit password, and get router info routing table all, and here also we have two routes from OSPF but not having any default route. Okay, now if you want to communicate to the outside through these PC, so we have to inject default route. So we will inject a default route with the help of OSPF. Okay, so let's go to the firewall 1. Here we have a firewall 1, and go to the OSPF and scroll down little bit, and here you can see we have a one option called inject default route. Okay, so we are using OSPF 0, the area 0. So you can select here as a regular areas. Okay, and metric type is the route types. We have a two types of route in OSPF, E1 and E2. Okay, type 1 refers to E1 and type 2 refers to E2. I'm not going in depth to explain you what these routes are. You can learn it from the networking guides. Okay, let me give you a small introduction. So type 1, which refers to E1, is the route cost, which includes the external cost plus the internal cost of the OSPF to reach the boundary routers. Okay, and E2 routes are the routes which only include the external cost. Internal cost is ignored in this type. Okay, so in short, E1 routes stands for type 1 and is equal to external cost plus internal cost, but in E2 it only refers to the external cost. Okay, and rest of the things keep it as a default and hit apply. That's it. Now go to the CLI mode and let's check if they are getting the default route or not. Okay, so we are on firewall 3 here. So let's apply the same command and here we go. You can see O star E2. E2 means type 2 routes, which is E2 OSPF external type 2 route, and O means learning from OSPF and star is candidate default. Okay, and in similar way you can see on firewall 2. Here also we are getting routes E2 OSPF candidate default route. Okay, now these firewall starts communicating to internet. You can see here we go. They are communicating, right? Okay, now if you change it to the type 1 route, type 1 metric, just click here type 1. Okay, let me show you other way. So just go to the firewall here and here you can see what is the administrative distance is 1110 and what is the cost. It's a 10 here, right? And in the similar way in firewall 3 we have 110 and 10 because we are using E2 and E2 is having only external cost. Let me change it to E1, then we will see what cost it's getting. Okay, so let's select the type 1 and hit apply. Okay, so wait for few seconds to make the communication happens. So here we have a destination unreachable as of now. So let's wait. Now here we go. It started again. So let me see it in the other PC. Yeah, it's started. Now go to the CLI to check it. Okay, hit the same command. And here we go. You can see type E1 this time. Okay, and the cost is 11, which includes external cost, which is 10 plus internal cost, which is 1, because it's a 1 hop away and having a bandwidth or a cost 1. Okay, and you can see in firewall 2 also, and here also we have a cost 11 for the E1 route. We have a 11 this time. Earlier we have a 10 here. So I hope this makes sense to you guys, and I hope you understand something about OSPF today. And if you still have any questions or any concern, you can write down me a comment. I'm very happy to help you guys. So thank you for watching today's lecture. Have a good day. Bye bye. Take care.